about how to solve longer logarithmic equations. Okay, a few more steps than what we've done before. So just a bunch of examples. So here we're just going to dive into one. Now notice on this that you got three terms. 1, 2, 3. The first two terms are logarithms with the same base, right? If they're logarithms with the same base, you can condense them either using product rule, quotient rule, or power rule. Well, since there's a minus sign, this should tell you it's a quotient rule. So I'm going to condense it to one logarithm and put the x plus 1 on top, x minus 1 on the bottom. And it still equals 2. That hasn't changed. Now, remember the first step was to condense. The second step is to swirl. Well, 3 is my base, so 3 squared equals x plus 1 over x minus 1. Well, we know that 3 squared is 9, right? Now I'm going to cross multiply. So if I do this, I have x plus 1 equals 9 times x minus 1. Distribute out your 9. And we're going to solve it for x. I'm going to add 9 to both sides. Subtract 1. So so I have 10 equals 8x. Divide by 8. And x is, if I reduce that 10/8, I get 5/4. So when you're doing longer equations, you want to make sure that the value you end up with is legitimate. Okay, what I mean by that is that you cannot take a logarithm of a negative number. So you have to eyeball this and think about it. Okay, 5/4, it's 1 and 1/4. So if I put it back into my equation, the first logarithm, 1 and 1/4 plus 1 is still positive. 1 and 1/4, if I subtract 1, is still a positive 1/4. So it would still work over here. So this is a good solution. Sometimes we have what are called extraneous solutions that do not work when you put them back in the equation. So you're going to have to check and make sure it does not make the log turn negative, okay? Because that will not work. It's impossible. Let's try another one. 3 terms again. 1, 2, 3. But notice they're on different sides of the equal sign. They have the same base, so if they were on the same side, I could condense them using one of my properties. So I'm going to subtract this logarithm over here on the right so that I can get them all on the same side. So I now have, well, log base 2, 5x plus 4, minus log base 2 of x minus 1 equals 3. Now, since they have the same base, I can condense this using product rule because there's a minus sign there. So 5x plus 4 over x minus 1 equals 3. All right, let's swirl this thing. So 2 cubed equals 5x plus 4 over x minus 1. Well, 2 cubed is 8. Hopefully you know that. So when I cross multiply, I get 5x plus 4 equals 8 times x minus 1. Distribute out my 8. And I'm going to solve it for x. I'm going to subtract 5x from both sides. So when I subtract it, I get 4 equals 3x minus 8. If I add 8 to both sides, I get 12 equals 3x. Divide by 3, x equals 4. 4 is a positive number, so let's just check our equation, make sure it still works. 4 times 5 is 20, plus 4 is 24, so that's positive, it works. 4 minus 1 is 3, which is positive, and it works. Okay? So I checked, and this is a valid solution, not extraneous. Okay? With this one, 3 terms again, 1, 2, 3. We need to condense. This time it's a plus sign, so hopefully you remember that that means a product rule. So let's do this. So I have the log base 12 of x times x plus 1 equals 1. And then I need to swirl it to get rid of the logarithm. So 12 to the first power equals x times x plus 1. Now, if I multiply this out, I get x squared plus x, right? So now, look, it's quadratic, which means two solutions. Okay, quadratics is two solutions, but I need to still solve it. So in order to solve it, I need to get 0 on one side of the equal sign. The quickest way to get there is to subtract 12 from both sides. So I have 0 equals x squared plus x minus 12. And then I have to factor it. All right, two terms that multiply to negative 12 but add to a positive 1. Well, that would be a negative 4 and a 3. Since the coefficient of x squared is just a 1, I can just plug them in like that. And then I would solve. So x would equal 4. And this one, if I put x plus 3 equals 0, x is equal to negative 3. Now, go back and look at the solutions here. If x is 4, will it work in the first term? Yes, because that's positive. 4 plus 1 is 5, so it works there. So this is a good solution. What about negative 3? Can I take the logarithm of a negative 3? No, I cannot take a logarithm of negative 3. You will get an error on your calculator if you try. It does not exist. Okay? And here a negative 3 plus 1 would give me negative 2. Again, it's a negative number, not going to work. So this is extraneous. So this, although it was quadratic, it only has one good solution. Okay, so you always have to check, because if you have two solutions and one of them doesn't really work, then you really don't have two solutions. So you have to check those solutions first. All right, on your own, I want you to try this one. When you get to class, we'll go through it, but I want you to go as far as you possibly can, even potentially solving it, and always check for extraneous solutions. All right, we'll see you in class.